If you want to learn how to measure and plot temperatures, build wireless radio controllers, use servos to drive tools, or build weird things like, I don't know, a thermal camera, here you'll learn mechatronics in minutes. In this tutorial, we're going to learn the most basic utility in the Arduino programming interface, and that's communicating with the Arduino through the serial monitor. This monitor gives you the ability to see what's going on inside your microcontroller, so you can test readings, debug code, and even input instructions. There are two activities that you will need to do. First is turning on the serial communications. This is generally done in the beginning section of your program, and the command is serial.begin parentheses 9600. We'll be writing in the C programming language, so pay careful attention to the syntax, capitalization, and don't forget to add a semicolon at the end of each line. The argument or number in the parentheses is the data rate or baud rate and must match the setting in the serial monitor. I'll show you that setting later. From a terminology standpoint, serial is an object and begin is a method or function associated with the serial object. Some objects also have properties, but that's for a future tutorial. We can now begin writing data to the screen. The next command we'll learn is serial print line. You simply enter the data you want in the parentheses. This data or argument can be a string of characters or a number. Since we're adding this code in the setup section, expect it to display only once. Let's upload the code and see the results. Make sure you have the correct board and port selected. Then upload the code with the left arrow button, or from the main menu, or just hit Ctrl and U. But wait, nothing seems to be happening. Next, we'll access the serial monitor to, monitor stuff. Click the serial monitor button. Find it on the menu or hit Ctrl-Shift-M. The second window will display and show any serial activity. Make sure the baud rate section in your monitor window matches the 9600 we specified earlier. Here we go. Hello world right back. Printing in setup is great for verifying setup procedures. Let's see how we can display something repeatedly. The loop section is intended for continually doing operations like measuring something and adjusting a motor speed. But for now, let's keep it simple and loop through some numbers. I'll add a global int variable and call it I. Global variables can be accessed anywhere in your program and are a pretty common way to create variables you will use frequently. Then in loop, we'll print I, but increment it by 1 time in each iteration. Incrementing will be done with the good old-fashioned I equals I plus 1. Notice how I established the variable in a completely different part of my program, but change it in this loop function. That's the whole point of a global variable. Upload the code and see the results. The display is so fast it's hard to see what's going on. The next command we're going to learn is delay, and it will tell the processor to delay. The argument is the number of microseconds you want the processor to wait. How about 1/10 of a second? So we'll enter delay 100. Now you can see the data and actually read the values. What about data that has decimals? Change the int to a float, then change the increment to something weird that will generate lots of decimals. How about I equals I plus 1 divided by 88? Hey folks, bonus points for someone who can comment on where the 88 comes from. Now notice how the value prints with 2 decimal places. The decimals default to 2, but we can change it. Try adding a comma 6 for 6 decimal places. I hope you're coding along with me and keeping up. If not, pause and retry. These fundamental concepts will help you later. There is another variation of print line, and that's simply print. Print does not advance to a new line and is very useful in printing multiple variables. Let's output the hex and binary equivalent to integers. This seems like busy work, but as you get more advanced in programming Arduinos, knowing hex and decimal values will be pretty useful. Change your I back to an int and change the incrementing line. This time I'll shortcut the code with simply I++. This example code will print a complex string of data with variables sprinkled throughout. The first line prints the stuff in quotes, but does not advance the line. Then we'll print I, then we'll print a comma. Notice the hex keyword, which will tell print to print the hexadecimal equivalent. Another comma, and another bin keyword that tells print to print the binary equivalent. Notice we're using print, so everything will print on the same line. Finally, we'll end with a period and a new line. This combination of print and print line is extremely useful in debugging code. Imagine seeing in your serial monitor, line 342, the voltage at pin A0 is 2.331 fan output is 0. You know the line number, the inputs, the outputs, and you can determine if things are happening as expected. So far, we've been dumping data to the serial monitor, but you can input data to tell your Arduino to do stuff. This practice isn't real common, and since I'm trying to keep these tutorials short, I'll cover that in the future. As you try things on your own, here are some tips if serial monitoring isn't working. Make sure serial.begin is in your setup section, and make sure the baud rates match. You can write more than one variable to the screen, but I'll save that for the next time, where we'll learn how to measure analog sensors. Well, that covers this week's lesson. If you learned something, give me a thumbs up. If you have a tip to share, leave a comment so my subs can learn more. Thanks for watching.